For today's section, we're going to talk about complex numbers. Hopefully you remember from last year that the variable I we typically use to represent imaginary, and that stands for the square root of -1, and that complex numbers have a real part, which we usually denote with an A, and an imaginary part that we usually denote with the letter B. So to write a complex number in standard form, it's the real part A plus the imaginary part B with our I. So just a few examples here. It says to rewrite in terms of I and simplify. So if you remember, we can take the square root of -3 and rewrite it as 3 times -1. And then from our properties of radicals, we could rewrite that as the square root of 3 times the square root of -1, which we now know turns into an I. So we could rewrite this as I times the square root of 3. We usually put the i's in front. That way we make sure that we know that they are not underneath the radical still. So for our next example, the -5 is hanging around outside, and we could rewrite the 8 as 4 times 2 times -1. And so if we break those apart, you have the square root of 4 multiplied by -5, and the square root of 2, and the square root of -1. So the -5 is still there, the square root of 4 is 2. Square root of 2 we can't do anything with, and the square root of -1 turns into I. So to simplify this, we would have -10I, the square root of 2. You can do the same thing for 75. Hopefully you remember that 75 is 25 times 3. Also the negative sign still in there, so we could rewrite this as 5I square root of 3. The square root of -56, if we simplify this, we could write that as 4 times 14 times -1. If you don't remember those factors, you can always do your factor tree. So that top would turn into 2 plus 2I square root of 14 all over 6. And since we could factor out a 2 in the top, we should do so. And it's still all over 6. And then that 2 and 6 will reduce. So you'll have 1 plus I square root of 14 all over 3. And while that is simplified, it's not in standard form. In order to do that, you need to separate your real part, which would be 1/3, plus the imaginary part, which would be square root of 14 over 3I. To add and subtract complex numbers then, you're just going to combine like terms. So all of your properties still hold. Your commutative, which deals with the order, doesn't matter when you add anyway. Associative, that's how they are grouped together. And then distributive has to do with multiplying. So all of those properties still hold. So for example 5, we can distribute this negative sign or -1 to both of those, giving us 13I minus 14 plus 7I. And then you want to combine your like terms, and again if we're going for standard form, write your real part first, so -14 plus 20I. For example 6, it's helpful to reduce your square roots first of all. So hopefully you remember that 8 turns into 2 square root of 2, but it's -8, so it's going to be 2I times the square root of 2. And then plus 5 minus 50 is 25 times 2, but again it's negative, so it'll be 5I square root of 2. And so now we're going to combine our real parts to give us 3. And since they're both a square root of 2, we can combine the imaginary parts, giving us minus 3I square root of 2.